through the exam questions that I gave you on the immune system, because especially the specific immune response can be a bit detailed, and maybe I hope you're able to understand it with the video. But anyway, the first question in the exam question was: an outbreak of measles occurred in Ireland during the summer of 2016. Name a group of people who would be most at risk. Well, those that had not received the vaccine as a child. So those that hadn't been vaccinated, okay? What is a vaccine? Okay, now if you're asked to describe a vaccine, you're going to say that it's a treated dose of the virus. So like the most common vaccine, I suppose, that we're familiar with is the MMR. When you're a baby, you're given it 3 months, 6 months and 12 months, I think. But so the MMR is a vaccine that defends against measles, mumps and rubella, okay? So you're given a treated dose. It's treated in a certain way so that it can't replicate. So the virus cannot replicate. So like it wouldn't infect your cells. You wouldn't have symptoms of measles, mumps or rubella. But what it does do is it introduces the antigen to your body. So your body now can recognize this foreign antigen, and your body then, your B lymphocytes, will start to make antibodies. Now that reaction takes a few days, you see, but you've got antibodies now, and you also, of course, have memory B lymphocytes that will stay in your body, stay in your lymph system, stay in your blood plasma, and they go on patrol, if you like. And if you do when you go to primary school and you maybe become exposed to measles, mumps or rubella, then you have immunity now against the virus, okay? So it's not causing the disease. So in the marking schemes, they use the term non-disease causing. You do not have symptoms of the illness, of the disease, after you receive the vaccine, but it just introduces the antigen so that your body then can make antibodies against those viruses, okay? List 3 types of T lymphocyte. Well, we did these in the video. You have helper T lymphocytes, you have killer T lymphocytes, you have suppressor T lymphocytes, and then you have memory T lymphocytes. Now, just to distinguish again between T and B lymphocytes, they are both white blood cells, okay? They are both lymphocytes. They both have large nucleuses. They are both produced in the bone marrow. But the difference is that the B lymphocytes also mature in the bone marrow, but the T lymphocytes mature in the thymus gland. The other difference is that the B lymphocytes can make antibodies, but the T lymphocytes cannot. So we are not going to be talking about production of antibodies for any of these T lymphocytes here that we're asked to give the functions of. Now, in the video, sometimes when I say B cells, I mean B lymphocytes. When I say T cells, I mean T lymphocytes. So I hope you're not confused by that. Now, you're asked to give a roll of each of 3. You're only asked for 3 in the exam, but anyway, we'll run through the 4 of them now. So what do the helper T cells do? Well, the helper T cells will recognize antigens, which are, remember, foreign molecules on the surface of pathogens. So they recognize the antigens, and the helper T cells stimulate the B lymphocytes to start multiplication and producing antibodies. And helper T cells also stimulate the killer T cells, okay? Now, so helper T cells, if you like, start off your immune response. Stimulate the B lymphocytes and stimulate the killer T cells, okay? Now, what do killer T cells? These ones are associated more with like infected cells, so like cancer cells, so abnormal cells, or virus-infected cells. And what they do is they release a chemical called preferin. So remember the word preferin, and remember preferate. So preferin is a chemical that's secreted by the killer cells into cancer cells or virus infected cells, and that preferin causes pores or holes in the cell membranes of the cancer cell, and it causes water and ions, remember we talked about that, to flow into the cell, and then the cell will eventually burst. So you mentioned something like that. Suppressor T cells then switch off your immune response, if you like. So once the pathogen has been destroyed, you want to stop the multiplication of B and T, B lymphocytes and the killer T cells. So you want to stop those from multiplying, and so it switches off your immune response. And then finally, the memory T cells then stay in your system. They go around, they will kind of go on patrol, I suppose, right? And they will look for anything that's foreign to us, look for the antigens. And if they recognise the antigen, then they'll stimulate the production of B cells again, so that your immune response starts all over again. Okay, so that was question 1. Now, question 2 then, outline how any one named feature of a human now there's loads of features of the general defence. So you could talk about the skin, you could talk about the sweat and the sebum that's produced by your skin, and your skin being a barrier, if you like, to stop the entry of pathogens. You could talk about the cilia and the mucous membranes. You can talk about any of there's loads of general defence systems that we talked about yesterday, so any one of those would be fine. 2 organs. Now, here, look, it says that are specific. So I wouldn't go mentioning the skin there when they use the word specific in the question. Specific, I think, maybe implies to the immune system, the specific immune system. So you'll be talking about things like your spleen, your lymph nodes, tonsils, those kind of organs. Okay, now distinguishing clearly then between an antigen and an antibody. Well, there are your definitions. An antigen causes antibody production. Remember, generating antibodies, so causes antibody production. And then an antibody is produced by a lymphocyte in response to an invading antigen. Okay, so your 2 definitions would be perfect there. T cells then, look, they want you to describe the specific role of killer and helper T cells. Now, I did that previously. And then name the T cells that stop the immune response. So they'd be the suppressor T cells to stop the immune response. Okay. Question 3 then, what's meant by the term immunity? Well, immunity is the ability of the body to resist infection. That's just a definition again. And then it says outline briefly the role of the B lymphocyte. So this would essentially be the poster thing that I was doing out for you in the video. So what you'll have to say about the B lymphocytes, firstly, is that they recognise antigens. So say that a B lymphocyte recognises an antigen on the surface of a pathogen. Remember, a pathogen is a disease-causing microorganism. Now, remember also that you have B lymphocytes that are dormant, thousands of them, dormant in your body, and it's there's a particular B lymphocyte specific to the antigen that's after invading. And that B lymphocyte, the one that is specific to the antigen that has invaded your body, that's the one that will multiply. So you'll say that B lymphocyte multiplies, and then that B lymphocyte produces lots of antibodies, and that antibody then attaches to the antigen on the surface of the pathogen and tries to destroy the pathogen that way. Okay. Then don't forget then maybe to say about the memory B cells that remain in your plasma and in your lymph system, and they'll remain for years, and they go on patrol, as I said, and they will recognise any foreign antigen that might invade again in later years. Okay, so that's kind of the video that I was showing you yesterday. Distinguishing between passive and active immunity. Well, the big thing there is that with active immunity, you made the antibodies yourself. So your body makes the antibodies. Whereas with passive immunity, the body does not make the antibodies. Okay, you were given antibodies that have been made in other organisms. So the body doesn't make the antibodies if it's passive. Then the next part, 4 there says, vaccination gives rise to active immunity. Now, you must be careful there with the active immunity. Why will a vaccine give rise to active immunity? Because remember what we said about a vaccine a while ago? So a vaccine is introducing the antigen to your body. So you're giving a non-disease causing dose of this virus into your body. The body will acknowledge or recognise the antigen and make antibodies itself. So that's why it's active immunity, because your body will make antibodies, in response to the antigen yourself. That's what that's what the vaccination will do. Okay. And then the last part says, in certain situations, a person might be given an injection. So you're given an injection of antibodies. And like in the video I was saying to you, something that you might be familiar with would be like a tetanus injection. So when would you be given a tetanus injection? So you'd be given a tetanus injection if you're about to travel abroad. You'd be given a tetanus injection if you got a bad cut from a rusty nail or something. You'd be given a tetanus injection if you got a bite from a wild dog or an animal like that. So would that be an example of active or passive? The tetanus injection are injections of antibodies that will work against the tetanus pathogen, okay? So it is passive because you're being given the antibodies. Your body is not making the antibody for itself. You've been given the antibody. Under what circumstances might an antibody rather than a vaccination be given? Well, you'd be given the injection of antibodies if you've already been bitten. So say like you've been bitten or you've been cut badly, and the infection is probably already kind of taking hold, if you like, and you need to go quickly and you need to get an injection of the antibodies fast. Okay, if there was no vaccine for a particular illness, then they would use injections of antibodies. That would be another instance where you would be given the injection. So if there's no vaccine available, or if the infection is already on kind of there, like a vaccine takes a while to produce the antibodies. But if you've just gotten bitten, or if you've just gotten the cut and you suspect tetanus is going to set in, then you need to get your injection quickly. Comment on the duration of the immunity. Well, it's short-lived. That's why like when if you are going traveling abroad or anything like that to going somewhere, then they will check, when did you last get a tetanus injection, because it is short-lived, because you don't produce the antibodies yourself, you see, so you don't have memory cells that will last in your body for a long length of time.